The launch of NASA's Explorer probes marked the beginning of an extraordinary journey into space, demonstrating humanity's ability to monitor not only Earth but the entire solar system and beyond. Even after 46 years, these incredible spacecraft continue to provide scientists with fresh and surprising insights about the universe. Although their memory is 3 million times smaller than that of modern smartphones and they're thousands of times slower than our fastest 5G networks, these probes remain pioneers in space exploration. Explorer 1 recently made a stunning discovery in interstellar space, challenging long-held beliefs about the universe. It found something so perplexing that it has scientists scratching their heads. But what exactly did it uncover, and how does it change our understanding of the cosmos? On a historic day, September 5, 1977, from Cape Canaveral, Florida, Explorer 1 launched into space aboard a powerful Titan rocket. Just 15 days later, on August 20, 1977, Explorer 2 embarked on its journey. Initially, their mission was to study the gas giants like Jupiter and Saturn and their moons. But these spacecraft went far beyond their original objectives, venturing deep into interstellar space and breaking records along the way. They have traveled farther than any other human-made object, and today they are over 12 billion miles from Earth, still surprising scientists with their findings. In their early encounters, the twin probes provided invaluable data. Decades ago, they closely observed Jupiter and Saturn's moons, completely changing our understanding of these distant worlds. Before this, scientists thought these moons were desolate and barren like our own moon. However, they discovered active volcanic activity on Jupiter's moon Io, with eruptions so massive they dwarfed any on Earth. The images from the probes revealed Jupiter's dynamic weather patterns, including the iconic Great Red Spot, and even faint rings around the planet. In addition, Explorer 2 was the first spacecraft to fly by Uranus in 1986 and Neptune 3 years later, making it the only spacecraft to have visited these distant planets. As NASA continued their journey, engineers turned off unnecessary components to conserve power, allowing these probes to keep working until at least 2030. For the scientists and engineers who have been part of this mission from the start, the unexpected discoveries bring mixed feelings of excitement and nostalgia. The data sent back by Explorer 1 and 2 has become a treasure trove of scientific insights. These meticulously designed probes captured clear images and gathered data as they sped through space. Even early on, their images of Jupiter left researchers in awe. One of the most remarkable findings came when Explorer 1 detected volcanic eruptions on Io, a moon far more active than anyone anticipated. One eruption from Io's Pelée volcano shot debris higher than Mount Everest, covering an area nearly as large as France. These missions revealed other surprises, like Jupiter's faint rings and Europa's thick icy shell, over 60 miles thick. The findings raised exciting questions about the possibility of life on icy moons like Europa. As the explorers left Jupiter, they received a gravity boost, helping them break free from the Sun's pull and continue on to Saturn. Explorer 1 went on to observe Saturn's moon Titan, with its thick, hazy atmosphere, while Explorer 2 later provided our first close-up look at Uranus and discovered 10 new moons around it. When Explorer 2 reached Neptune, it observed winds reaching speeds of up to 1,000 miles per hour, the fastest in the solar system. It also studied Triton, Neptune's largest moon, which turned out to be one of the coldest places in our solar system, with nitrogen geysers erupting from its icy surface. The data from these probes has shown us that even distant, frozen worlds can be fascinating. One of the defining moments of the Explorer missions came from Carl Sagan, who championed the idea of capturing one last set of images as the probes ventured farther from the solar system. On Valentine's Day in 1990, Explorer 1 turned its camera back toward Earth and captured the iconic pale blue dot image from 3.8 billion miles away. This became the farthest photo ever taken of Earth, showing our planet as a tiny blue speck in the vastness of space. Despite the decades that have passed, the Explorer probes continue sending valuable data from the edge of the solar system. Remarkably, they still use 8-track tape systems, a technology popular in the 1970s, highlighting the ingenuity of the mission's engineers who ensured these tapes could withstand the test of time. When space exploration was just beginning, digital storage technology was in its infancy. To manage vital data, something reliable and powerful was needed, and 8-track tapes turned out to be the ideal solution. But these tapes aren't just filled with ordinary recordings. They hold invaluable scientific data about planets, moons, and the space between stars. These tapes contain answers to some of the greatest mysteries known to humankind. The Voyager spacecraft faced extreme conditions in space, such as intense hot and cold temperatures, space radiation, and the vast emptiness of space. Remarkably, these old explorers have continued to function, like sending your grandparents on an expedition to Antarctica. And not only do they survive, but they thrive. The Voyager missions utilized a clever technique called a gravity assist. Imagine Voyager 1 and Voyager 2 as two robust space explorers on a mission to venture deep into our solar system. To reach their distant targets and gather valuable data, they needed more than just their engines. This is where gravity assists come into play, allowing the spacecraft to gain speed from the gravitational pull of large planets. By performing a sort of cosmic dance with planets like Jupiter, Voyager used the gravitational pull of these massive bodies to sling themselves forward, conserving fuel and gaining the speed needed to visit multiple destinations. A gravity assist, also known as a gravitational slingshot, works by gaining speed from a planet's gravity as the spacecraft passes by. Imagine Voyager 1 approaching Jupiter, a massive gas giant with a gravitational pull to match its size. Scientists at NASA's Jet Propulsion Laboratory precisely calculated Voyager 1's approach to Jupiter, ensuring it passed by at just the right angle and speed. Jupiter's gravity pulled the spacecraft forward, giving it an energy boost like a cosmic power-up. If Voyager 1 had approached incorrectly, it could have veered off course. Fortunately, the NASA engineers perfected this move, making the Voyager missions a tremendous success, showcasing the precision and innovation behind them. These gravity assists enabled Voyagers 1 and 2 to accomplish extraordinary feats in space without depleting their fuel, like winning a cosmic race with style. The Voyager probes are now famous, not just for their journey but for the special item each carries: the golden record. Think of it as a space mixtape, containing greetings, music, and sounds from Earth, designed to give any intelligent life out there a glimpse of our world. This component of the Voyager mission, inspired by Carl Sagan, is like a time capsule for potential civilizations to discover and learn about us. In 2012, something monumental happened. Voyager 1, after more than 35 years exploring the vastness of space, achieved something no other spacecraft had done. It crossed the heliosphere, the protective bubble created by the sun's particles and magnetic field, and entered interstellar space. This marked the first time a human-made object had ventured beyond the sun's influence and into the uncharted space between stars. Interstellar space, a region filled with mysteries, is unlike anything scientists had directly observed before. Voyager 1's crossing of this boundary, known as the heliopause, led it into a realm where the sun's influence fades and particles from other stars become more prominent. This transition into interstellar space allowed scientists to collect invaluable data about the conditions there, including information on the density, temperature, and magnetic fields of the interstellar medium. Voyager's instruments, designed to last only a few years, continued to operate remarkably well, sending back data that challenged existing theories and introduced new questions about the nature of our universe. Voyager 1's journey offered insights into the transition zone between the heliosphere and interstellar space, revealing it as a turbulent region rather than a smooth surface. This provided a better understanding of how our solar system interacts with the rest of the universe, influencing theories on stellar wind bubbles and the overall structure of the Milky Way. Voyager 1's entry into interstellar space also had significant implications for future space missions, including potential human exploration of distant planets. The data Voyager collected on cosmic radiation outside the heliosphere, where the sun's magnetic field no longer shields against high-energy particles from beyond our solar system, has been crucial in planning future deep space missions. The impact of Voyager 1's crossing goes beyond scientific discoveries. It symbolizes humanity's desire to explore, to push beyond the known, and to venture into the unknown. Carrying the golden record, Voyager 1 is not just a scientific tool. It's a message from Earth to any intelligent beings that might encounter it, filled with sounds and images that represent the diversity of life and culture on our planet. Voyager 1's historic crossing into interstellar space in 2012 marked the first time a human-made object left the protective bubble of our solar system. This achievement provided scientists with unprecedented data about the interstellar medium, challenged existing theories, and opened new questions about our galaxy. The journey of Voyager 1 continues to inspire us and remind us of our innate desire to explore and understand the universe. Incredibly, even after decades, the Voyagers are still making remarkable discoveries in the darkest corners of space. For over 10 years, they have explored beyond our solar system, sending back valuable information about places we can't easily reach. Then, something truly astonishing happened. Voyager 1 detected a strange signal from deep space. This mysterious signal seemed like something out of science fiction, sparking excitement among scientists who knew it was a significant finding, though they didn't yet understand what it meant. So, as we conclude this amazing story of the Voyager mission, we can marvel at these spacecraft, born from human curiosity and innovation, which began their journey over 40 years ago. They were not only about exploring our solar system but about pushing the limits of what's possible, both in space and in the human spirit. As they continue their journey, the mysterious signal they received reminds us of the vastness and wonder of the universe. Each new discovery made by Voyager 1 and its twin brings us closer to understanding the immense, exciting, and sometimes bewildering cosmos we live in.